Hello everyone and welcome to today's session. In this session, we will explore one of the common Salesforce governor limit errors, too many DML statements 1. We will begin by understanding why this error occurs, particularly in the context of Lightning Web Components and Apex. Then I'll walk you through multiple strategies you can use to effectively resolve and prevent this issue in real-world scenarios. Let us dive in and learn how to build robust governor limit safe applications. To give some background, in Apex, we can enable client-side caching by using the cacheable equal to true property in the aura-enabled annotation. This is especially useful when working with Lightning Web Components, as it allows the framework to automatically cache and refresh data efficiently. However, there is an important restriction you need to be aware of. When a method is marked as cacheable equal to true, it runs in a read-only context. This means you cannot perform any DML operations like insert, update, or delete inside such methods. If you try to, Salesforce will throw too many DML statements 1. In many real-world scenarios, you'll often want to log information such as diagnostic details, warning messages, exception messages, or errors. Typically, these logs are written back to a custom log object in Salesforce. But here is the challenge. If you're trying to do this from within a method marked as aura-enabled cacheable equal to true, DML operations are not allowed because the method runs in a read-only context. This restriction can make logging difficult, especially when you're trying to track errors or performance metrics in real time. So we need to explore alternative approaches to handle logging without violating platform limits. Don't worry, we will look at some clean and scalable solutions to work around this limitation. So for this demonstration, I created some sample code. Let me quickly share my VS Code. If you see the JavaScript code, it's very simple. I'm just calling the getContacts method. I'm fetching some columns from the contact object. I'm getting contacts using the wired method. I'm calling this particular getContacts method. So my HTML is also very simple. So I'm just displaying using a Lightning data table. I'm displaying all the contacts that I'm retrieving using my Apex method. And if contacts are not returned for some reason, I'm displaying an error. If you go back to the actual Apex class, the Apex class is also very simple. So I have a getContacts method, which is retrieving a list of contacts. So using a query string. So I'm retrieving ID, first name, last name, email, phone from contact, and I'm retrieving around 100 contacts. And using database.query, I'm querying this object. And then after this, my requirement is I want to actually log using System.Log.Utils. So what I did, I actually downloaded a package, a non-unmanaged package from Play, which is called System Log Tracker, which provides me the respective objects for logging, and it also provides me a very good UI. So I am just using that functionality. I have not developed that. I have just downloaded it from Play. This System.Log.Utils.insert system logs, what it does, it actually inserts a log. So if you see the System.Log.Utils underlying class, so this is actually downloaded from Play, as I told you. It has got various methods for inserting logs. You can insert logs, you can insert the log based on log level. So it has got various methods. And I'm using one of the method for inserting a log called insert logs. So using this method, I'm displaying if it is an exception or record ID. I'm using one of these method. I'm using this second method, insert system logs, providing the log level, the message that I want to do, the record ID. So it internally prepares a log and it inserts a system log. So if you see the insert system log, it is actually doing a database insert. So it is internally calling one more insert system logs. So eventually what it does, it actually inserts data to a database. So it inserts data to an object called a system log, so which has various fields. So it inserts data into that system logs. That is what I am trying to do here. But as I told you, since this method is declared as cacheable equal to true, when I perform a DML operation, it eventually errors out. So let me show you the UI so that it makes things very clear. So here I created something called Workinator app where I have all my examples. So here I added this governor limits component that I created. So if you see here, so contact list, DML error. So it is errors giving error fetching data because I was performing a DML operation and it is giving me this too many DML statements one. Coming to these exceptions, right? There are various use cases. So if you see here, I'm doing two logs. One of the log is of type information, the other type is of error log. So since both of these are insert operations, the code is failing in this line number 10 itself. It is going to exception, trying to log an exception. It is also failing. To actually resolve this issue, depending on your use case and the various performance considerations that you have. The simplest, least efficient approach is to remove cacheable equal to true from the RR-enabled annotation. This allows you to perform the DML operation because the method no more remains a read-only method. But you will lose benefits of client-side caching, which can impact performance and responsiveness in the UI. A more elegant solution is to throw it the exception from read-only Apex method back to the Lightning Web Component. Then in the Lightning Web Component JavaScript, you can call a separate imperative Apex method, one which is not cacheable, to perform the necessary DML operations such as logging. Alternatively, you can offload the DML operation to an asynchronous process like a queueable Apex job, which is typically ideal for bulk and background processing, or a platform event, which allows for decoupled event-driven logging or integration. Each of these strategies ensures compliance with platform limits while keeping your application efficient and scalable. Now let us go to the first method. So one of the easiest method to resolve this issue is just by removing cacheable equal to true. But this is only possible only when your Apex method is called imperatively from your Lightning Web Component JavaScript. If Apex method is called using wire service, this does not work. However, this approach comes with a trade-off. By removing cacheable equal to true, you lose the benefit of client-side caching, which means every time the component loads or refreshes, it will make a server call. This can significantly impact performance, especially in high traffic or data-intensive components. Keep in mind that this method is only valid for imperative calls. If your LWC is using the wire service to call the Apex method, then cacheable equal to true is required. Without it, the component will throw another runtime error. So while removing caching might be a quick fix, it is not always the most efficient or scalable option, especially in larger applications. Now let us see the demo for this removing cacheable equal to true. Now for this demonstration, what I did, I made a couple of changes in my code. The first thing that I changed is where I went to my DML error simulator JavaScript. And earlier, if you remember, my JavaScript, the actual Apex method was called using wire. And as I told you, when this removing cacheable equal to true is only possible when your method is called imperatively. So for that reason, what I did, I created one more method called fetch contacts, which is where I'm calling this get contacts method. I'm calling get contact methods in fetch contacts, and I'm calling this fetch contacts method in connected callback. So whenever the first time the page loads, this connected callback will call the fetch contacts, and it will fetch the contacts and then return the result back. Now, and the other change that I did for this to work is I went to my component, my Apex class, and I removed cacheable equal to true on my line number 3 from get contacts method. Now this method is no more a read-only method. So this is a method which actually is called imperatively now, and it is not cached. So let us see how this works now. So if you see, I don't have any logs in the system. So let me close this and go to governor limit section. When I go to governor limit section, now I don't see any error. So all my contacts, 100 contacts that I've downloaded will be displayed for me. Now, when I go to system logs tracker, if you remember, I was logging two logs, one info log and one exception log. Here there was no exception. That's why I will not see any exception log, but I'll see the info log. So where I was actually capturing the query, the source and application module, whatever, right? So all this information is properly logged in my logger right now. But the other problem that I want to show with this cacheable, when you remove cacheable equal to true, I told you that it is not going to utilize the client-side caching. So to demonstrate that, when I go to this governor limit section, if you see every time I click this governor limits tab, you will see this execute method executed multiple times. So if you see this is executed here, now I click one more time. So there is one more time this goes to server, gets the data. So whenever I go and refresh the tab, so it makes an execute call separately to the server, which makes my component more inefficient because it has to go to the server and get the data and display the data. Assume that the query was not that great and it was not selective. Assume that my query takes, say, 10 seconds. So every time it will go to server, spends 10 seconds, get the data and show the data back to me. So this makes my UI component more inefficient. So that's why I recommend not to use this approach. A more efficient and scalable way to handle this error scenario is particularly for exception handling, is to throw the exception from the read-only Apex method back to the caller, which in this case, it's a Lightning Web Component JavaScript. So in LWC, catch the exception that was thrown from Apex, and then invoke an imperative Apex method, which is not marked as cacheable equal to true, to perform a DML operation, such as logging the error. This approach typically works well for exception handling because exceptions naturally propagate and can trigger follow-up actions in your JavaScript. However, it is important to note that this pattern does not work for logging informative or warning kind of messages, since you can't throw exceptions in those normal execution paths. For those cases, you will need to consider other mechanisms like asynchronous operations or other design pattern to actually log these messages. Let us see the changes that I made for this demonstration for using imperative method. So if you see my code now, what I did in my same code that I already earlier had. So in the JavaScript, I brought back this void method. And if there is any data, so I'm storing it in the data variable. If there is an exception, it comes to else if error block. In the error block, I'm actually calling an imperative method, which is actually creating the error message. This imperative method is taking multiple parameters. I'm passing all these messages to the parameter and logging it accordingly. Now coming to my actual Apex code, I made this cacheable equal to true again because this is the efficient way of doing it. And as I told you, this method only helps in logging exceptions. So for actually logging an exception, what I did in my query, I added a field which is not existent. So I added a field called test. Test does not, there is no standard field called test. I'm just adding this field here to ensure that I get an exception. So this typically throws a query exception. So I'm running this query with a field which is not there in my object. Now this will throw me an exception. When it throws an exception, it goes to the catch block. Within the catch block, what I am doing, instead of actually logging it here directly, I'm throwing the exception back to the caller. In this case, this method is called from my Lightning Web Component. So I'm throwing the exception back to Lightning Web Component. So in my Lightning Web Component, I catch that exception because it comes to the error block. So this is where I actually get the error body message. If the message is available, I'm storing exception message. I'm storing the stack, error body stack. I'm storing all this logging information. Then I'm calling this method called log from LWC. So I added one more method in my controller, which is not made cacheable equal to true. So which is a non-cached method. The intention of this method is it is just going to log the data using the system log utils and it is inserting the log. So instead of directly storing the log from my cacheable method, I'm throwing the exception back to the caller, and the caller is calling this method imperatively. And remember that this method is not cacheable equal to true. So this will actually resolve that kind of issue. Let me share my other screen and see the demonstration. And I'm calling my governor limit section. So since you know that my query has a field which has a problem, that's why it is still giving me an exception in my component. It is not displaying my contact names because I'm querying a field which is of type error. The intention here is to show you that my logging works when there is an exception. So here, if you go to system logs tracker and refresh the system logs tracker, you should see the error log, which actually tells error fetching contacts, no such column test on entity contact that I got from my query exception. So I'm just sending it back to my log, and log from DML is actually logging that particular exception properly. So this helps in actually doing exception handling properly when there is an exception in my cacheable equal to true method. So the second method, which can be used for logging any kind of messages, is using Queueable Apex. So Queueable Apex, which allows you to execute logic in isolated asynchronous transaction, completely detached from the main thread. This method is especially useful when you want to offload operations like logging without impacting the performance or limits of your main Apex logic. Compared to future methods, Queueable Apex offers several advantages. Like it supports non-primitive data types such as S objects and custom Apex classes, which is not possible in future method. You cannot pass them directly. Uh, then job chaining, there is an option to chain jobs, which means you can enqueue a queueable, one more queueable job from this queueable job, which is ideal for sequential tasks. And it also has a finalizer where you can define follow-up actions after a queueable job finishes. This makes Queueable Apex a powerful and flexible tool for handling operations like info, warning, and error exception logging in governor limit safe way. When using the Queueable Apex approach, it is important to be aware of few key platform limits to avoid hitting governor exceptions. So there are some job limits per transaction. So if the transaction from where you are queuing a job is synchronous, you can enqueue up to 50 queuable jobs from this transaction. You can only enqueue one job if the context is asynchronous. So the other advantage of Queueable Apex is you get elevated CPU limit of 65 seconds, and you also get an elevated heap size limit of 12 MB, which can be used when working with larger data sets. So the best practices that you need to follow whenever you are using this methodology is to avoid enqueuing a large number of queuable jobs in a loop from a synchronous transaction. Doing so can quickly consume your argwide asynchronous limits, which are determined based on your addition and based on your number of Salesforce licenses. Instead, it is always a best practice to batch your log records and enqueue them in bulk or use job chaining wherever required. So you should always design your queuable usage with scalability in mind to prevent hitting these limits like async limits in production environments. So it is essential to validate all platform limits before adopting the Queueable Apex approach. So to reiterate, you should always bulkify your operations, which means like combine multiple log entries or records into a single job instead of enqueuing separate jobs for each log entry. So if you have more number of records than the limits allow, typically I consider 200 records as a safe number. So when there are more than 200 log entries that you want to add in one go, it is better to chain or to split this into batches of 200, use chaining by chaining one more queuable job and processing those records in background. This not only helps you stay within your limits, but also ensures that your solution is scalable, efficient, and governor limit safe, especially in high volume environments. Always plan and test your queuable logic under realistic data. to ensure it behaves reliably in production. So for this demonstration, I've actually developed a Queueable Apex job, which is designed to handle bulk operations, bulk logging records efficiently. So typically the job that I have written typically accepts a list of records, and if the number of records is greater than 200, it splits them into chunks of 200 and uses a chaining option in Queueable to chain the job again with the next batch. So this approach typically ensures that you stay within your DML limits per transaction. It avoids hitting asynchronous limits prematurely and achieves a scalable long processing even in large volume scenarios. It is clean governor limit safe solution that demonstrates the power and flexibility of Queueable Apex in real world use cases. So as I told you, I created a separate class called System Logs Queueable, which implements Queueable. And if you see, this is a bulkified queueable job, which typically means like I'm accepting multiple logs that I want to insert into database. And I'm also doing in my execute method, I'm setting the batch size as 200. If I have batch size greater than 200, if I have more than 200 records in my context, which is logs to insert, what I'm doing, I'm splitting that into 200 records and I'm inserting those 200 records in the first go. Then I'm doing the same thing. So for every batch size, if it is less than batch size, I'm just getting these batch size records. If it is greater than batch size, I create a remaining batch. There is a remaining batch available, I enqueue it again with the remaining batch. So say if I have 600 logs, so this will execute, this will enqueue 3 queuable jobs, one after the other using the chaining mechanism. The other change that I made in my actual controller method, which is called from my JavaScript. It is still cacheable equal to true. But earlier I was actually handling exceptions. I was not doing any logs here. I was just handling exception because imperative method that I used earlier only allows for exception handling. Here I can handle both information and exception logs. So here what I am doing, I removed the test variable here. So now I don't have any exception in my query, but I'm logging an information log saying that I'm just logging an info log. I'm storing the query string that I'm executing, and I'm storing all the other information that I need. I'm adding it to logs. So if you see, I created system logs here. I'm constructing a list of logs, and to this list of logs, I'm adding these system logs using the unmanaged package that I downloaded from Play. So I'm preparing a log, adding it to the system logs. And after getting all these logs, I'm enqueuing those logs using system.enqueue job. So using system, if log size is greater than 0, I'm enqueuing it using system.enqueue job. So I'm enqueuing the job. It will execute my queuable job, take 200 records at a time per batch, and insert those into a database. Let us go back and see how it works now. So I'm going back to governor limits. Now, if you see, there is no exception because my query is proper. It works fine. But I also have inserting a log, but this time using queuable job. So if you refresh this, you should see an info log. There is a queuable job. It runs in the backend. So it may take a minute for it to load. So if you see, my queuable jobs are queued. Currently, there is no resource available. That's why they are still queued. Yeah, one of them is completed. I click 2 times. That's why you see 2 logs. So if you go back to system logs, you should see 2 logs in the system log screen. Yeah, so both of them info logs. So I'm just storing the query details and other information that I passed. So let us see one more approach using which you can actually solve this problem. Uh, so it is through our event-driven architecture called platform events. This approach is ideal when you need to handle logging or processing in a lightweight manner. If you want to decouple the logging logic from your main Apex flow and to run this process asynchronously without blocking the main thread. Platform events allow you to publish event messages subscribed by using triggers or flows. These subscribers then handle the actual data processing, such as creating the log records in our scenario, but using a separate asynchronous context. However, it is important to note that platform event triggers do not support callout, and the events that you actually publish are processed in the order they are published. All processing occurs under synchronous governor limit errors. So batch sizing is also very critical here. Platform events also have their own specific limits. So this method works best when the logging logic is simple, fast, and doesn't require external API calls. It is a great way to build a decoupled and scalable logging mechanism in Salesforce. Platform events are typically published after the database transaction is committed, which ensures that only successful transactions trigger the event. Here are a few important behaviors to keep in mind when using this kind of implementation. The events are delivered in order they are published, preserving the sequence of operations. While platform events run asynchronously, the triggers or flows that process them operate in a synchronous context. This means that synchronous governor limits like CPU and heap size limits still apply in the processing logic. So even though platform events provide asynchronous decoupling, you should still be careful with large payloads, complex logic inside the trigger, and especially the batch size to avoid governor limit exceptions during processing. This approach is excellent for lightweight logging or event-driven processes, but always evaluate your use case against these platform behaviors and limits. So I created a separate Apex class called System Logs Publisher, which actually publishes logs. So it will take a bunch of system logs that I insert from my Apex class and goes through each of these system logs and create log events from that. And then it publishes the log events. So I created a platform event, which is called log event. So publish immediately. So if you see this log event, it has got all the fields, and not only that, it has a trigger. So within this log event trigger, so I'm going through each of these events that were published. And from that, I'm creating a system log. I'm creating multiple system logs and inserting the system logs from the platform event trigger. So I publish it from my code, and then I actually use the these subscriber trigger, and from the trigger, I create the actual system logs. Let me share back my code. So I made some changes in this also. So here I'm doing the same thing. I'm adding it to system logs. But the only change that I made here is if logs are available, I'm calling the system logs publisher.publish logs. So this will actually publish the logs to system logs publisher. And the publisher will take these logs, go through each of these logs, and then publishes it to the bus. Once it publishes to the bus, the subscriber will actually read this data, take the data, and iterate through the data and create the actual system log records in the database. Now let us see how it performs in the UI. When I go to governor limit, since there is no exception in my code, everything works fine. But if you see the logging will happen, but through platform events. So platform events will be a bit quicker because they are near real time compared to queuable jobs. So when it comes to handling the too many DML statements issue in Salesforce, there is no one size fit all solution. So it's always recommended to choose the approach that best fits your design and business requirements, taking into account factors like data volume, governor limit errors, performance impact, real-time versus asynchronous processing. Each method, whether it is an imperative Apex call or a queuable job or a platform event, has its strengths and weaknesses. My recommendation is to use a hybrid approach. Use imperative calls for controlled exception handling. Use Queueable Apex for batch safe background DML operations. Use platform events for decoupled event-driven logging. By leveraging a mix of these approaches, you can build a solution that is flexible, scalable, and governor limit resilient. Hope this video helped you. Thanks for your time.